Hello, welcome to lesson 3B-4. Today we're going to be converting between different forms of quadratic equations. Specifically, we're going to be looking at moving from vertex form to standard form and from standard form back to vertex form. So our learning target today is that I can convert quadratic equations to different but equivalent forms. So just a reminder before we get started of what our vertex and our standard form looks like. Our vertex form is going to look like y equals a times the quantity x minus h squared plus k. And our standard form is going to look like y equals ax squared plus bx plus c. These are both forms we've worked with in previous lessons. So if you need to review what the individual terms in those formulas stand for, you can go back and look at particularly the first two lessons in 3B, 3B1 and 3B2. So we're going to first look at some examples where we're converting from vertex form to standard form. So we are going to be going from the first one listed here to the second one listed down here. So when we are doing this, it's a pretty simple process. When we're going from vertex form to standard form, all we are going to have to do is expand our part that is squared and then combine like terms. So we would expand the x minus h portion and then we would combine any like terms that we have. So let's go ahead and jump into some examples. So looking at example number 1, we are given f of x is equal to x minus 1 squared plus 8. So what we are going to do is we are going to have to expand the x minus 1 squared. So remember, to square something means to multiply it by itself. So we are going to take x minus 1 and multiply it by itself, x minus 1, and then we still have the plus 8 at the end. So what we are going to do next is we are going to multiply these two binomials, and we are going to take the first term times the first of the second, and an x times an x is going to give us x squared. We're going to take the first term and distribute it to the negative 1, and we're going to get negative x. Then we need to look at the second term and distribute it. We're going to take negative 1 times x, which is going to give us another negative x, and we're going to take a negative 1 times a negative 1. Remember, a negative times a negative gives you a positive, so we're going to have a positive 1, and then plus the 8 at the end. So our last step that we're going to have to do on this is to combine like terms. We only have the 1x squared. We do have a pair of negative x's, which is a negative 1x and a negative 1x is going to give us a negative 2x. And then I have a positive 1 and a positive 8, which are going to add together to give me 9. So if I am looking at this, just to illustrate that this is in standard form, this does match our ax squared plus bx plus c. You can see we have the x squared term, we have the x term, and we have the constant. So we have completed converting this from vertex form to standard form. Pretty simple process. We're just drawing on skills we've used before to expand our term that is squared, and then we just combine like terms. So let's look at one more example, going from vertex to standard form. We'll look at example number 2. So we would have f of x is equal to 2 times x plus 3 squared minus 5. Now this is a little bit different because we have a factored out term right there with the 2, but we're not going to treat this much differently than before. For right now, we're going to leave that 2 where it is. We'll come back to it later, but we want to go ahead and expand the x plus 3. So it's x plus 3 squared, so we would have x plus 3 and x plus 3. And then we always want to make sure we don't leave out that constant that's at the end of our vertex form. So I'm going to again save my 2, and I'm going to go ahead and expand the x plus 3 times the x plus 3. So I'm going to do x times x and get x squared. I'm going to do x times 3 and get 3x. I'm going to do 3 times x and get another 3x. I'm going to do 3 times 3, which is 9. And then I'm going to have the minus 5 at the end. Now notice that when we're multiplying this term times this term times this term. This minus 5 is going to be a separate little piece off to the side here. So what we are going to have to do now is we're going to have to combine like terms within our parentheses. We can't combine anything outside of it yet because we're still being grouped together. So I would have an x squared, a 3x, and a 3x is going to give me a plus 6x, and I have plus 9, and then I still have the minus 5 at the end. The thing that's going to be different this time is that I am going to have to distribute this 2 to all 3 of my terms within the parentheses here. So if I distribute that 2, I'm going to get 2x squared plus 12x plus 18 minus 5. So now I can do my last step of combining like terms. I have just a 2x squared, I have a 12x, and then I have a plus 13. And that has combined all my like terms, and I have converted this example right here into standard form. So that wraps it up for vertex form to standard form. It's pretty simple. You'll follow this process in each step when you're asked to convert from vertex to standard form. What we're going to look at next is going the other way, going from standard form into vertex form. This method is just a little bit different. It might be a little bit trickier to get the hang of it first, but it's still not too difficult. So it says in our notes that there are 2 methods. We are only going to show one because we think that this is the easiest method, and we think that this is going to be the one that is quickest and most efficient for you to use. If you are struggling with this particular method, feel free to see Mrs. Blaylock or I, and we will go over the other method with you, but this is going to be a method that we really think that you will prefer to the other one. So we're only going to cover method 1 in the notes, so we're going to go ahead and jump into that. So finding the vertex is going to be the first thing we need to do when we're converting from standard form to vertex form. So the first thing we're going to have to do is to find our x value, or the h of the vertex, by using x equals negative b over 2a. That's something that we used in the first 2 lessons when we were graphing to find our vertex. The thing that we're going to do to take it one step further is we're going to find the y value, or the k, of the vertex by plugging in x into the original equation, or by substituting it. And our a will always be the same. So we're going to then write an equation by using your values for a, which will be the same as your standard form a. You're going to have the h, which is negative b over 2a, and you're going to have k, which is what you get when you substitute x back in. So just a quick recap, if we are looking at standard form, or vertex form rather, this would be f of x is equal to a, that's the a we're talking about, times x minus h, which is the negative b over 2a, plus k. So what we're really plugging in when we're going from standard form to vertex form is we're plugging in the same a. Alright, the h is basically going to be our negative b over 2a, and our k is going to be when we evaluate the function at negative b over 2a. Now this looks a little confusing when you are looking at this in the general form, so we're going to go ahead and jump into a couple examples. We're going to flip back and forth to the slide so we can follow our process through, especially with the first example. So we are asked to go from f of x equals x squared plus 6x plus 8, and we're going to take it from standard form to vertex form. So just to help me out, I'm just going to put what my a, my b, and my c is going to equal. My a, since there's no number there, is going to be a 1. Our b is going to be 6, and our c is going to be 8. So if I flip back to our notes, the first thing I have to do is find the x value, or h, by using x equals negative b over 2a. So x is going to equal negative b over 2a. So I'm going to plug in. My b was 6, so I have negative 6 over 2 times a, which is 1. That's going to give me negative 6 over 2, which is going to give me negative 3. So this was step 1 from my notes here. Step 2 is we have to plug that back into the original equation. So step 2, I'm going to take my negative 3, and I'm going to plug it back in to my original equation. So I'm going to do f of negative 3 is equal to, and it's important especially when we're doing negatives to use our parentheses. That way we're making sure we're keeping any negative signs with the terms that we're squaring. If you don't put the negative or the parentheses around this negative 3 and you type this into your calculator, it is going to spit out an incorrect answer. It's going to square the 3 and then stick the negative in front of it instead of thinking that it is negative 3 squared. So it's a good idea to add those parentheses in. Plus 6 times negative 3 plus 8. So we are going to simplify. Negative 3 squared is going to be a positive 9 minus 18 plus 8. So I get f of negative 3 is equal to, let's see, 9 minus 18 is a negative 9, and negative 9 plus 8 is a negative 1. So if I'm looking back at my steps, I have now found my h and my k, and my a will be the same. So sorry, I went back the wrong way. Step 3, I know that h is going to be negative 3, k is going to be negative 1, and a I'm going to pull from all the way up here. A is equal to 1. So the last thing I need to do, if I am looking back, is plug that into our equation. So I am going to write this as my final step. Oops, sorry there. Let's see if I can figure out some space to do this. So we would have f of x equals, our a was 1, times x minus h. Now it is minus h. Our h is negative. If we have a minus a negative 3, that's going to become a positive. So instead of minus 3, we're going to have plus 3 squared, and then plus our k, which would be plus a negative 1. Now most times when you see this, you will go ahead and you will have that 1 will be invisible, since 1 times anything is 1, and you would have x plus 3 squared minus 1 as your final answer. Alright, so we got one more example, and I'm going to copy and paste this onto hopefully a new page so that we have a little bit more room to work. Go ahead and feel free to make sure that you have this copied down before we go on. And I'm going to try and add a new page here. I've not done this in the middle of a presentation, so let's see if we can do that. There's an insert blank page, so I'm going to copy and paste that in. Since we've already done example 3 and I'm not too worried about seeing that again, I'm going to move example 4 over the front and center for us. And let's go ahead and work through this last example. Alright, so let's jump into this example. We are going to go ahead and label our A, our B, and our C. So A is going to be 2, B is going to be a negative 8, and C is going to be 4. So the first thing I have to do is my negative B over 2A. This time it's going to be a negative 8 over 2 times A, which in this case A is 2. A negative and a negative make a positive 8, and 2 times 2 gives us 4. 8 divided by 4 is going to give us 2, so I know that that 2 is going to be my h. Now we have to find our k, so I'm going to plug that 2 back in. So I'm going to do 2 times 2 squared minus 8 times 2 plus 4. F of 2 is going to give me 2 times 4 minus 8 times 2 plus 4. So I'm going to do my multiplication next. 2 times 4 is going to give me 8, and negative 8 times 2 is going to give me negative 16 plus 4. 8 minus 16 is going to be negative 8, and negative 8 plus 4 is going to be a negative 4 when I simplify that out. So I now have my k value. And the last thing I'm going to need to do is to plug this in. So when I plug this in, I am going to have f of x equals, remember our a this time was 2, so we need to put that down. We're going to do x minus h. H was a positive 2, so we're going to do minus a positive 2 squared, and then we're going to have plus a negative 4 or a minus 4 at the end. Alright, so that is going to be our final answer. We have converted that into vertex form from standard form. So that pretty much wraps up today's lesson. Make sure that you pick up an application 3B-4 from the Algebra Embassy. This is going to be your first application for Unit 3B, so please make sure that you remember to go ahead and grab that. Remember, you can find the application video to help you out directly below this video, so make sure you give that a watch. And let us know if you need any help, and once you finish the application and the practice, go ahead and start preparing for your mastery check. Alright, this concludes the lesson for 3B-4. See you guys in the next lesson.